Find the vertex of the quadratic function f of x equals 3x squared plus 24x minus 42 by placing it in standard form. The standard form for a parabola is y equals a times the quantity x minus h squared plus k. So right now we're not in standard form. We are looking at y equals 3x squared plus 24x minus 42. So basically we need to put this equation in standard form. In order to do that, what we need to recognize is that the standard form has this quantity squared. It's a perfect square. And so how do we get that? We get that by completing the square. Okay. Now completing the square is basically us exploiting the relationship between these coefficients here and the ones that would appear in the perfect square. As a quick example, we take the quantity x plus 7 squared. It multiplies out to be x squared plus 14x plus 49. And we just exploit the relationship between the 7, the 14, and the 49. That's what completing the square does. In completing the square, you start off with just the squared term and the x term. So you get the 7 by taking half, and then you get the 49 by squaring. And that's what we're going to do here. But to start the process of completing the square, you have to have the coefficient on x squared be a 1. So we're going to start off by factoring out a 3. And it just so happens that we don't want to, I know it looks strange, but we don't want to do it from the entire equation. We're going to do this. We're going to basically take this part here, make it a perfect square, and deal with the 42 later. And so factor out a 3 from this first part to give us the following: y equals 3 times the quantity of x squared plus 8x minus 42. Here's what we're going to do. We're going to add something inside with the 8x and the x squared to make this guy into a perfect square. But in order to do that, what we have to do is at the same time we add it, we need to take it away. And so we have so that we keep the equation balanced. And so here's how it works. Let's leave a blank space. Let me rewrite that with a blank space. Y equals 3 times the quantity of x squared plus 8x plus something that we're going to add minus the 42, and then plus something that we're going to take away. We have to be very careful here because with the 3 it actually confuses things. So let's exploit that relationship. Let's take this part here like we did with the 14x, and we're going to turn this guy into a perfect square. How do we do it? We take the x, we take the plus sign. Now just like we did with the 14, we took half of that to get the 7, we take half of the 8 to get the 4. So from here to here we take half. And then just like we did with the 7, we square that to get the 49. So from here to here we're going to square. So when we square 4, you get 16. Let me change the color. We get 16. So you think, well, we're just adding 16. If we add 16, everything works out. You have a nice perfect square, but be very, very careful. We're not actually adding 16. Believe it or not, we're adding 16, but the 3 that's on the outside plays a role. It's going to multiply the entire perfect square, so it should actually also multiply the 16. And so 16 times 3 is 48. What we've actually added was 48. Okay. If we were to multiply this thing out, there'd be a 48 as the constant term, and so that 48 that we've added needs to be taken away to keep the balance. And so here we have then the final result would be y equals 3 times the quantity of x plus 4 squared, and then between the negative 42 and the negative 48 we end up with, yeah, I guess negative 90. And so the vertex, once you're in standard form, is hk. It's the standard form is a times the quantity x minus h squared plus k. And be careful how you read off the h and the k. When you have a plus there, it's because it's minus a negative 4. And then the negative 90 at the end is just the value of k. And so it turns out for us then that the value of h is negative 4 and the value of k is negative 90. And that's our vertex. And I guess that's the answer to the question. That's what they were looking for. They asked us to find that, and so that's our answer. That's the vertex of that particular parabola. If you were to graph it on a graphing calculator, you'd see the low point being exactly there. Negative 4, negative 90. Okay, complete the square, but be careful completing the square. In order to do it, you have to factor out the coefficient that's on the x squared. Okay, great. You get that final answer.